So again, let's begin with our programming part 2. So today we are going to study about matrix subsetting. Earlier we also have studied lots of things about matrix, how can you access the elements of the matrix, but again there are some other ways to access those elements also, and there are some tricky questions, tricky syntax about the matrix subsetting. So let's go with it without wasting the time. So yeah, let's begin with it. When it is required. So here we can see we are trying to access these following indexes, but how we are accessing these indices? So when I use these indices, for example, in the place of x I have in the place of the row I have inserted a vector, and also in the place of column I have inserted a column number. Okay, that is a raw column number. So why we are getting here output 2 and 8? This is the question. So here we have C, oh my god, and I guess we have 1 and 3, 1 comma 3, yeah, and we have 2. So if I want to transform this, I can do this thing. Okay, this way I can transform it. So the we can say it is a combination of 1 and 1 and 2, which is row plus coulomb, row plus coulomb, yeah, and also we have 3 and 2, 3 and 2, which is also row plus coulomb, row plus coulomb. So if I look at very closely here, I am going to access the, or the R, not I am exactly, the R will access the first row and the third coulomb, no, the second coulomb, okay, and then R will again access the third row and second coulomb. So first row, second coulomb, third row, second coulomb, and these things will give us two results. So let us see again that again the thing, okay. So what was the first thing? First row, second coulomb. So this is the first row and second coulomb is 1, 2. So here 2 is the, this 2 is the first second coulomb and 2 is in the first row, okay. Yes, it is not associativity, it is a distributive property, okay. So as we can see, this is A into B plus C, so we will do A into B, A into C. So it is something like this, okay. But here we are not performing any operation here. So but this is something like distributive property we have to use, okay. And also we will also use commutative. Let's move on. So I am turning off the mic right now because it will make a noise. Okay, so let us see that when I do not place any value here in the in this right hand place. Okay, so what will be the output in this case? Again, there is one thing I want to know here, that I have not given here any comma. So by default it is just only containing one single element. Okay, so let's see what will be the output in this case. So yeah, we have got an output in this case, so that is 1 and 7. Yeah, that is very interesting. We are getting here 1 and 7. So if I look at the matrix again, so let's look at the matrix. So I am getting here 1 and 7. This is 1 and this is 7. So what it means, that we can say that it is accessing the first row, and what I have written that third row. Okay, so it is only accessing that first row and third row, but the first element, there is no column index for this thing. Okay, so the by default we can say that column is, by default we can say that column is the first column. So what we can refer here, so again I am going to Excalibur. Okay, this is not the thing. So here, okay, let's see. It doesn't matter. Okay, so let's see what we can refer here. So if I have this C of something like 1 comma 3, so it means first COL coulomb. Okay, first coulomb, first row, first row plus first element. Okay, so since it is given already, first coulomb, first row, and first coulomb, coulomb, first third row, So what it is printing, that first coulomb, first row, first coulomb, third row. Okay, so this coulomb factor is implicit in nature in case of this example. So we do not know that what is happening inside, that which coulomb it is identifying, but by default the coulomb is first. Okay, so DEFA, default coulombs is 1 if it is not mentioned, So that is, and that is the analogy we can give here. So the default coulomb is 1 if it is not mentioned. This is something interesting we can say. Okay. Let us see the next our next example. Okay, so where we have give here a comma. Okay, here we can see that we have not given any comma. Despite it, the default coulomb is the first coulomb, and we are getting this first row and third row, whatever is in the particular first coulomb, and we are getting that the first index of the first row and third coulomb respectively. So again, if I check here, so let's see what is the output. Oh, this is really interesting to see. Now we are getting a complete row. Okay, now we are getting the complete row. So yeah, complete row of complete row 1 and row 3. Okay, so here only first element, default coulomb is 1. So coulomb 1 plus first row and coulomb 2 plus third row. This is the coulomb 1, okay, coulomb not 2, coulomb 1 plus third row. This is something really interesting to see. But here the scenario is completely flipped 180 degree. So we can see that here we have not got a particular coulomb here. When I place comma, this comma, okay, that is the main thing. We have placed a comma, just a single comma can change the entire output of the statement, okay, R statement. So again, why it is happened, that is decided by the scientist, okay, whoever designed this R programming, or basically it is designed by a group of statisticians. So they want that it should be appear like this. So this is what it is, that's why. So when I do not place any value, it will take the all three coulombs. It is not taking only one coulomb. We can infer like this, okay. So so we can infer like when we do not mention any coulomb, coulomb explicitly, explicitly along with a comma, we can along with comma, we get by default all the three, okay, by default all the three coulombs are selected with respective rows written in vector format. Okay. So this is the analogy we can give, that when we do not mention any coulomb explicitly along with a comma, by default, okay, mention any coulomb explicitly, but mention, okay, we can say that, but we use a comma, okay, we use the comma, then by default all the three coulombs are selected with respective rows, okay, written in the vector format. So what we can say that, okay, this should be like I want here red, okay, I want it to be red. So what I will do here, okay, this should be black. So if I have this 1, 3 and I am not mentioning here anything, but there is a comma I have placed, and this is the thing I want here. Okay, so in this case, so here I have not written, okay, here I have not written anything. So this time, so the result will be enter first row and enter third row. Okay, so what I will get, enter first row and enter third row. So that means all the columns are default selected, all the elements in the columns are selected, but in this case only the first column have got selected. So this is the difference between these two statements. Again, we have to do lots of experiment to understand other syntax analysis on this also. Okay, so let's go to the next example. Okay, let's go to the next example. What will be this? So we have done this already, and now let's see this. So now if I place here 0 explicitly, so let's see what will happen. Yes, if I place here 0, so no columns are getting selected. Okay, that is no columns have got selected. So output is just column indices. So again, it may be also asked in some exams. So the column indices will be there or not. So the answer is no column indices will be shown in the console output. Okay, so here only we can only see the row things. Okay, the row indices. But again, it is a very interesting thing that we can see here. So we are getting only 2 row indices. We are getting here with only 2 row indices. This is something interesting really. Again, I want to mention the 2 row indices only that have got print in the console. Okay, now let's do some other interesting thing. Okay, so I want, before doing it, I want to do one thing again. I want to do one thing. Let's say if I do this, so let's copy it, and I do not want to write it again and again. Okay, so what if I do here not available? This is also a type of class. So let's see what it. Okay, so now we can see that this is an error. So here we will get a error. So if I place there NA, so it will be an error. So if I place here, let's say not a number. Okay, so let's see what will be here. Okay, I have done it wrong. Okay, now it can run. Okay, it is, why it's not running? Maybe, okay, there should not be any issue here. Okay, it's running currently. Yes, this is also an error. Object mat. Okay. Object mat not found. Oh, I have done something wrong here. Okay, there is a small typo error. So I'm really sorry about it. Okay, so object mat, that means that I have a typo error. So let's run it again. Okay, so we have got, okay, we have got 2 rows and all the columns are being selected and filled with NA. And if I use this, let's say, okay, this is again really interesting thing. Okay, and I have got only 1 row with 2. That is really amazing to see. Okay, so we have got selected only 1 as per my understanding here. So let's study it one by one. So this is NA. So what I have selected, 2 rows I have selected, so that's why I am getting here 2 rows, and all the columns are by default selected. So So let's copy this thing, and again I am going to discuss here. Okay, just come below. Yeah. Okay. This will be really interesting thing to see. So the result is all the elements, okay, enter row 1 and row 3 got selected, or we can say enter all 3 columns are also got selected for row 1. All 3 columns are or have got selected. That is one good observation we can say. For row 1 and row 2. Okay, for row 1 and row 2. This is one observation we can see, but the most important observation is all the elements for row 1 and row 2 is not available. This is for this statement. So the first row and third row with all the columns have been selected. Again we can see that all the elements for the first row and third row with all the columns, if there is a 3 number of columns, then it will be 3 number of 3 NS per row will get printed. Okay, so that's really interesting. So that is again very important. So remember, we always have to remember this, that this 1 and 3 represents row. Okay, this 1 means first row, 3 means third row, and NA means all the elements will be NA. And we also have another observation, that is NAN. Okay, so again I am going to analyze that also in more detail. Okay, so let's print this thing again. So I will change it to NAN. This is n small a, that means not a number. In this case, what I will get here, this is something interesting. So only one column got selected, only one column got selected, if I am not wrong. So let's check it again. No, this is not correct exactly. Only one row got selected. Row got selected. Okay, so only one row got selected. Interesting, very interesting. So again, but why the output contains 2 NS? The output contains 2 NS. So we can say, okay, let's do it more interesting. Let's do it more interesting. So how many rows I have in the original matrix? We have 4 matrices. Okay, so if I do this, so let's say this is an experiment. Okay, I am not saying so will I get here 3 NS? So let's run it and see. Yes, so that means So if I give here 4, I will get probably 4 NS, and 5 is out of bound. So let's see what will be the output in this case. So if it is out of bound, so that means there will be an error. Basically there will be an error. But if I give here 4, so that means 4 NS I am getting here. So that means what I can infer from here, which is really important. Only one row got selected. The row will only contain NA. Number of NA is based on the selected row number. No. Number is we can say is same as how many rows are in the vector, is same as, or we can say is equal to, number of NA is equal to number of rows, or number of, we can say, this is something interesting, number of, we cannot say here in the vector these are rows, we cannot say that. Okay, number of indexes, we can say I and D, indices. Okay, this is wrong spelling. Okay, what kind of, damn. Number of index in the vector. Oh my god. So number of index in the vector. So how many number of index is there? 1, 3. So that's why the result is, in this context, it is something like the one row have been selected, and we have to place, I think there is a comma. No, there is no comma with her. So that is also very interesting. This is not an indices. Okay, we can say it is a vector. Okay, only one row got selected. So I think we can say, no, result is a vector. We can say, so this is not a indices. Okay, the result is a vector. The result is a vector. VC. The result is a vector. The vector will contain NA. The vector will only contain NA. Number of NA is equal number of index in the vector. So how many index? 1 and 2. So that's why the output in this context is what? NA and NA. So this is one kind of statement where the result I am getting is a vector, not a matrix, or not a row of the matrix. This is a complete vector. So how can I understand? Because there is no comma in this one. So if there is no comma, so that means it is a vector. Okay, but here we can see always that there are commas already present in this. So these are matrix indices, we can say, and we can change the names. Already we know how to change these names of these indices. There is a name attributes, and if I do this, so let's say MAT 1, we have C 1 to 4, okay, and I do it NaN, that means not a number. So again I will get this output again, but number of ns will get increased to 4 times. And that is, again, we have to know always I should write here if number of if indices so this is the analogy we can give here. So the result is a vector, and if the number of indices goes beyond the out of scope, the result will be an error. So this kind of experiment we always should do. Again, there are remaining experiments, so let's do it very quickly without wasting the time. So we have got this. So what will happen now if I place here okay, if I place here a 0, I am getting 2 rows, okay, but these 2 rows are empty, okay. We can see only the 2 indices of the row, okay. And let's see this -1, okay. So let's run it. This is something again interesting. So here I am getting 2, 3, 8, 9, okay, 2, 3, 8 and 9. So we are getting here 4 elements. So we always know that when we place a negative number in a matrix, so it truncates the rows and columns, okay. It truncates rows and columns, or it may truncate also elements also here. So let's see what it happens. So if I use the distributive property, so I am assuming it, okay. I have not tried it earlier, so that's why again I am also doing this experiment. So what will happen so let's see. So but I am assuming that it will also follow that the same distributive property 1 and 1 and 3 and 1 and 1. So if I do this 1 first row and -1 means first column, okay. So as per my expectation, so what will get, the first column should be deleted, okay. First column should be deleted, and also the third row, -1 means that first column, okay. -1 means first column again, so that means first column again the target is there, should be deleted. But why if I delete those things also, but in that case the result should be from first row and third row, okay. So the rest of the elements, okay, that may be true. So as if I use the distributive property, so as per my expectation, so what I did, the expectations of first row, first column should be got deleted, okay. First column should be got deleted, so the elements also should be from this third row and first row. So 2, 3, 8, 9 is from first row and third row respectively, and the elements what I am considering, that -1 is the first row, is the first column, -1, and 1 and 3 is the first row and third columns respectively, and got the, if it is I have dot deleted, okay, if I dot delete this thing, so then I will get these 4 elements in the console output. So this is really amazing thing, okay, and also very critical understanding should also require to or I think understanding also very important. You have to know that this follows distributive property and other things also here. And I think I have to make two parts of this thing, okay, because it will take lots of time, because I can only upload up to 16 GB file. So that is the restriction for me. And should I again to go to Excalibur and draw this? But it can be easily understood. So if I follow the same distributive rule, okay, so we got this 1 and minus 1, okay. So we got a pair of, so what I got, we got a pair of 1 and minus 1, okay, which does which means that first element of the first row, and also we got a pair of minus 1, 3 and minus 1, 3 and minus 1. So that means the third row, the first element of the third row, okay. So since there is a negative indices is given, so it will got deleted. The first column, entire first column will got deleted. So since I am considering only the first row and third row, so that's why the output will be also from that first row and third row. We will not consider the entire second row and fourth row. So the output will consider from this. So that's why 2, 3, 8, 9. So assume this is got deleted, okay. So that's how we can we got this output. So what if we use this or execute this, run this statement? So as you can see that the pair will be, so when we do, we can make a pair. So that means 1 and minus 2 will be there. So that means the first row and second column, okay. So the element is what? If I do this, the element will be this. So I will do it, definitely I will do it. So and the same way, so we have this 3 and minus 2, 3 and minus 2, okay. So if I remove this minus sign, so what will be the output in this case? In this case the output will be, that is very clear, 2 and 8. So let's see what I get the output if I remove this minus sign. Yes. So again, this is very interesting thing that we have got a vector, not, so initially also we got a vector. That is really interesting, okay. So in the experiment 1 also we got a vector here. Here what we got, this is also a vector. Oh, that's really amazing. So let's go to Excalibur. Let's go to Excalibur. Default column is 1, okay, if it is not mentioned. So what I got here, first column, first row, this is okay. We have not mentioned all of the thing in details, similar distributive property, but actually okay, our result is a vector. That is again very important. Here the result is a vector. Again I have typo. The result is a vector. This is some good observation we can see. the result is a vector containing two elements. So from here we can see that this is a vector containing two elements following the this will follow the two elements. So that is very important. And in the same case also here, if I do not give here, this is from here, but we use a comma, then by default all three coulombs are getting selected. So let's see. Okay, this is correct, this is correct, but if I do this, okay, so I have not printed here anything. Okay, first column, first row. Okay, this is standalone. Okay, this was standalone problem. So this was not mentioned. The result is a vector containing two elements. I should write here this thing. Default column is 1. No, here default column is not 1. Here default column is 2. Okay, because 1, 2, that is 1 and 2. So that's why 2 and wait. So in this case, this is the context of this problem. Okay, default column is 1. If it is not mentioned, the result is a vector containing. Okay, that is again very interesting thing. So what I am studying here, so this one is the thing. So it is also a vector containing two elements, and but this was also a vector containing two elements. That is, we have to know. This is the result is a vector containing two elements. That is very important. So it is not a matrix we are getting from here. We are getting a vector from this thing, what we say. Okay, so the result is a vector containing two elements. The default column is 1. Okay, we have got a default column is 1. If it is not mentioned, the result is a vector containing two elements. Okay, this is again, there is a typo, I forgot to write. And already we know that vectors are linear, but here again this is very interesting to say that the result is a matrix here. In this case, the result is a matrix. That is the biggest observation I can say here. The result is a matrix, is a matrix. So in this case, the result we got a matrix, and in this case also we got a result is in this what is in this case, if I place here not available, the result is a matrix. That is very important. The result is matrix. So here also we have got that result is a matrix. In this case also we have got a result is a matrix, but here we have got the result is a vector. This is something very important and interesting also. Oh my god. So here we have got the result is a vector containing two elements. That is very important because we have not mentioned any second argument for this matrix. So that's why we have got. So this is a matrix. Okay, that is again very important thing. We must know this is a matrix. Indexing method. There is a matrix already associated with it. So in this case also we are getting the result is a vector. Okay, so here also when I again studying the current problem, here also, so what is the thing? what I am studying, this minus 1. So I will get minus 1. So what I get here, in this case I am getting here a matrix, not a vector. That is very interesting. Again I am getting a matrix, not a vector. So what are the case when I got a vector? That is very important to know. So when I place this NaN, I got a vector. Okay, this is one case. When I place here 2, okay, I was studying this, so I got a vector, not a matrix. But when I place here a minus 2, I will get a, what I will get? I will get a matrix, not a vector. That is, this is the thing. So it will truncate the middle element. So these elements will get deleted, because earlier we got this 2 and 8 when I place a plus 2. But now this column is you can think that this column is got erased, and we have to select. We are only allowed to select this first row and third row, 1, 3, and select these 3 elements. And but the result is a matrix in this case. So we can say there are 2 scenarios. So we can say we have 2 scenarios. So we have 2 scenarios. One scenario is for vector, again I have a typo, vector. Another scenario is for matrix. Okay, so when I get a vector, suppose I have a matrix like this and I am printing, okay, I am doing something like this. So 1, so let's say 1 up to 3. I will get the entire row in this case. Am I correct? So what I have did that okay. So I have not tried it. So let's do it. What I'll get here. So mat1. This is a vector of 1, 2, 3, or I can directly write this thing, but let's see if I do this, and what I get here, it is a vector. So that means 1, 2, 2, 2 and 3, 2. So the result is a vector. So here the result is a vector, 1, 2, 3. Or if I do this also, one comma 3, and if I do this, the result is also a vector. This is something really important to understand. So I am getting a vector here, I am getting also a vector. So that means all the elements will be in the row format. Okay, but when I use this, let's say if I do this 1 comma 3 and I do here minus 2, so it is a matrix now it is a matrix. Okay, minus 3, and even if I place here also, if I place here 2, no, not 2, not available, that is also a matrix. This is also a matrix. It's very interesting. but if I place here a not a number, so this is a vector. This will be a vector, but this is a matrix. Interesting observation. These are very interesting observation. Not a number is also an interesting. Again, when I place 0, I got a matrix. When I place 0 also, let's say 1, 3. If I place 0 here, I will got a matrix. If I do not place anything here, I will got a matrix. With a comma, I will get a matrix. So it will select the entire row, that is correct. It will select the entire first row and third row. Let's see again. But if I do this, just only if I do not place any comma, if I do not place any comma here, 1, 3, okay, then I will get a vector which will contain the select the row of the first row and third row, and you can say that is a Coulomb also, but this is a vector. This is not a row and Coulomb indexes, but we can understand it. So just like this, we are selecting the first row and third row, and the first Coulomb is by default. So we can understand like that, but this is a vector. So vector doesn't have any row or Coulomb kind of thing. Okay. So for understanding, we can use this method what I have written before, but this is not the result is a matrix, but here the result is a vector. So this analogy, the first Coulomb, the second row, so this is not exactly correct, okay, because we cannot use this word that first Coulomb, first row. So we cannot use this thing, row and Coulomb, because vectors doesn't have this kind of things, row and Coulomb. That is for matrix. Okay. So this is also a part of observation that what we got, and this definitely we will got a vector here. Okay. So already I have mentioned I have got a vector in this concept, and this is the matrix creation. So in this part we have looked into that some outputs, but that outputs are of two types. So one type is vector type and another type is matrix. So matrix will definitely have some row indices and Coulomb indices in the console, and those outputs are like this 1, 2, so you can see this, there is a comma, these are all matrix. They have row indices and Coulomb indices, and we can access those elements by using those indices. Okay, but vector is a one dimensional, we can say homogeneous collection of elements. So this is a one dimensional homogeneous collection of elements. So when I use this thing, so I will get a vector, not a this syntax. Okay, when I follow this syntax, so I will get a vector, not a matrix in here. So if it is a matrix, so definitely it will also have some I think Coulomb indices, and because row indices itself is a vector like syntax, so definitely it is a vector. So again, there are some other cases for getting a vector. So for most of the cases, we can say that when we truncate rows and Coulombs, so we get a matrix. When we use NA, we get a matrix. So matrix are some special cases. So we can see that when we place here a NA, so the first and third row will get selected, but all the elements will be NA. 0, that means the first row, nothing will get printed, only the rows containing those two elements will get selected, indices only. Okay. So if I do not place, if I write here a comma and do not place any explicit value, the entire first row and third row will get selected, and the output is a matrix. Okay. And in this case also, there is NaN 1 and 3. So what we will get a vector containing two elements. Okay, for these two rows, two elements for these two rows, and all those elements will be NA. Okay, it is a vector. So this is also a vector and this is also a vector. This will contain the all 1, 2, 3. That means all 3 rows. Okay. And what is in this context? I am not placing here any comma here. So the first, so that's this is very complex to explain this thing. Okay. So as we cannot use the column and row term in this context, but we can say that the first element of the first row and third element of the third row will got selected by default. Okay. So in this case also we can say that only the first column is there, so the first row and third row is, so that is making a kind of matrix, but this is not a matrix, this will be a vector. So outputs are very important for any kind of competitive exam, because anyone may ask you. So always should be prepared for a gentleman asking question, because some more people ask question. Okay, because that's how define us. Okay, that's how we can say that who are we are intellectual persons in the society. So again, I will create another video regarding this topic again, because this video is already scratched out. Okay, so I have to create another video. So let's close this and wait for the next part.